we are going to review solving one-step equations today. You have been doing one-step equations since 6th grade. You did them in 6th grade. You worked a lot with them last year in 7th grade. We're going to review them today in order to get ready for the big equations that we have to do in 8th grade. Okay? Now, a couple things to remember about solving one-step equations. Your goal, your first goal, is to isolate the variable. We want to get the variable all by itself. We want that variable to be alone. X equals, Y equals, whatever. And the second thing to remember is that you use inverse operations. So, inverse operations. The inverse operation to subtraction is addition. The inverse operation to multiplication is division. You undo an operation by using the inverse operation. So, let's look at a few examples. Here, we've got x plus 4 equals 10. My goal is to isolate the x. I want to get x all by itself. I've got this plus 4 in the way. What's the inverse operation to adding 4? Well, I'm going to subtract 4. And the third thing that I didn't mention up here is don't forget the golden rule of equations, which is whatever you do to one side, you have to do to the other. One side of the equal sign, you have to do to the other. So if I subtract 4 from one side of the equal sign, I've got to subtract 4 from the other. I bring down the x. Plus 4 minus 4, that becomes 0. So x plus 0 is just x. It canceled. It went away. Bring down your equal sign. Don't forget your equal sign. And 10 minus 4 is 6. Couple of important things. Yes, I want to see this work. This is what your work should look like. We're going to get to some very ugly, very complicated equations later. And if you are not showing your work, you will miss them almost every time. So even on the easy ones, make sure you're showing your work. The second thing is don't forget that you can check your equation. We can take that 6, we can plug it back in, and we can say 6 plus 4 equals 10. It checks. Now, we're not going to show that every time, but know that you can check all your equations. Okay? Next one. T plus 9 equals negative 5. I'm trying to isolate t. I have plus 9. My inverse operation for addition is subtraction. So I'm going to subtract 9. Whatever I do to one side, I have to do to the other. So I have, what, a t. My plus 9 minus 9 goes away. Don't forget your equal signs. Now, be careful here. Negative 5 and negative 9. You can use a calculator. You can use your number line. If I have a negative 5 and a negative 9 and I combine those, negative 5 minus 9 is negative 14. I could check that. Negative 14 plus 9 is negative 5. All right, last one. 16 equals a plus 25. A lot of people don't like them when they're written this way, but don't let it confuse you. We're trying to isolate a. I have plus 25. What's the inverse operation to addition? Subtraction. Whatever I do to one side, I have to do to the other. So 16 minus 25. If I have a 16 and a negative 25, when I put those together, I get a negative 9. Don't lose your equal sign. Bring down your a. The 25 minus 25 is gone. Same idea with if the original operation is subtraction, the inverse operation is addition. U minus 3 equals 6. I'm trying to isolate u. I have minus 3. My inverse operation is plus 3. Whatever I do to one side, I do to the other. Bring down the, not the 6. Bring down the u. A minus 3 and a plus 3 goes away. Bring down your equal sign. 6 plus 3 is 9. Don't forget you can check these. If I do 9 minus 3, I get 6. It checks. Okay? Next one. Y minus 7 equals negative 2. It's y minus 7 because I'm trying to isolate the y. The inverse operation to subtraction is addition. Whatever I do to one side, I have to do to the other. Bring down the y. Minus 7 plus 7 is gone. Don't lose your equal sign. Negative 2 plus 7, you can use your calculator, use your number line, use your addition rules, and you get 5. Okay? All right, one more. B minus 30 equals negative 70. Written the other way, that's okay. We're trying to isolate b. It's minus 30. The inverse operation to subtraction is addition. Whatever I do to one side, I have to do to the other. Negative 70 plus 30. Use your calculator. Use your addition rules. We get negative 40 equals b. That minus 30 plus 30 goes away. I want you to try these. I want you to pause the video. I want you to try these 6 problems, then turn the video back on and check your work. How'd you do? If you missed any, go back and fix them. Check all your work and make sure your work shows like this. We should see one step for every problem. All right, now let's look at the inverse operations to multiplication and division. Here I have 5c equals negative 15. This operation here between the 5 and the c is multiplication. The inverse operation is division. And here's how we show division. Do not, under any circumstance, use the division symbol. It's not allowed in algebraic equations. So we're going to divide by using the fraction bar. So we're going to divide the left side by 5. We're going to divide the right side by 5. 5 divided by 5 cancels. That becomes 1c, and 1c is just c, equals negative 15 divided by 5. Your signs are different, so the answer is going to be negative, and 15 divided by 5 is 3. We could check this, okay? Always remember you can check. Is 5 times negative 3 negative 15? It is. We're good. Okay? Next one. 54 equals 9x. I'm trying to isolate x. The 9 is in the way. That is multiplication. The inverse operation is division, so I'm going to divide that side by 9, and whatever I do to one side of the equal sign, I have to do to the other. 54 divided by 9 is 6. My 9's cancel. They become 1, and 1 times x is just x, so x is 6. That's how you solve equations that are originally multiplication. Now, one-step equations involving division. Look at this. I have u divided by 4. What's the inverse operation to division? Multiplication. And here's how you show multiplication in a one-step equation. You go over to the side with a little dot. Don't use the times symbol. That will mess you up. And then whatever you do to one side, you do to the other. 6 times 4 is 24. Equals u. Now this 4 is really over 1, so those cancel, and we're just left with u. Next one. Y divided by negative 10 is 7. This is division. The inverse operation to division is multiplication. You show multiplication out to the side, so it's a little different. We're going to multiply both sides by negative 10 because we are trying to isolate the y. So we're going to multiply the left side by negative 10, the right side by negative 10. This is over 1, remember. That cancels, and y equals, my signs are different, so my answer is negative. 7 times 10 is 70. So you pause the video, you try these next 4, then turn the video back on and check your work. Check all your answers. If you missed any, fix them. If your work does not look like mine, make sure you fix it. If you show incomplete work with equations, you'll get to do stuff over, and you don't want to do that. So make sure your work looks correct. The next thing we want to look at is an equation where the variable has a fractional coefficient. That's a fancy way of saying there's a fraction multiplied by the variable. This is called a fractional coefficient. You learned how to do this last year. This is a review also, but if I have 4/9 x equals negative 16, I'm trying to isolate the x, and this 4/9 is multiplied by it. We can divide both sides by the fraction, but if you'll recall about division, you don't really divide by a fraction, you multiply by the reciprocal. So here's what you do when there's a fraction in front of the variable. You multiply both sides by the reciprocal. Okay, so I have 4/9 x equals negative 16. What's the reciprocal of 4/9? Do you remember what reciprocal even means? Reciprocal is when you flip the fraction, okay? So we're going to multiply this side. We're going to flip that fraction, and we're going to multiply this side by 9/4 and this side by 9/4. You show it out to the side, and you multiply both sides by the reciprocal. Here's why we do this. Look what happens. Those 9 cancels, those 4 cancel, and I'm left with x, which was my goal, right? I wanted to isolate that variable. Now we're going to put the 16 over 1. 4 goes into 16 4 times. My signs are different, so my answer is negative. Never lose your equal sign. Negative 4 times 9 is negative 36. Okay? Looks scary, not bad. Now, look at the next one. Negative 7/12 x equals 28. So we're going to multiply both sides by the reciprocal, which is negative 12/7. Whatever you do to one side, you have to do to the other. The 12s cancel, the 7s cancel, and I get x equals, I did that wrong over there, didn't I? That should be times negative 12/7. Sorry about that. Now, so I multiply both sides by the reciprocal. 7 goes into 7 one time, goes into 28 4. 4 times negative 12 is negative 48. All right, one more. Negative 2/3 x equals 6/7. Look for your variable. My variable's right here, so I'm trying to get rid of the negative 2/3. So I'm going to multiply both sides by negative 3/2. Maybe I'll do it right this time. Okay? This cancels, I'm left with x. Now, this one's not going to turn out quite so pretty. My 2 cancels and goes into 6 3 times. Notice my 3 and 7 don't cancel, so how do you multiply fractions? You multiply straight across, right? 3 times negative 3 is negative 9. 7 times 1 is 7. So my answer here is negative 9/7. Not as pretty, but that's okay. Leave it as that fraction, leave it improper, you're good to go. All right, you pause the video, try these 3, then turn the video back on to check your work. Did you get them all right? Check your answers, check your work, fix anything that needs to be fixed, ask any questions that you need to ask, and now you're ready to do your practice.